I am your tutor Luther Pamba, and I'm going to take you through limits at infinity and horizontal asymptotes. So by the end of this lesson, you'll be able to evaluate limits as x approaches negative, either negative or positive infinity, and also connect them to horizontal asymptotes. So for any key positive integer n, so the limit of a function 1 over x power n as x approaches infinity or positive infinity will always be equal to 0. And also a limit of the same function, but as x approaches to negative infinity will also always be equals to 0. Example 1, I've got rational functions which are divided by highest power. So example 1, limit of a function x 3x squared plus 2x all over 5x squared minus 1 as x approaches to positive infinity. So as we have said, any rational function like this one will divide everything by the highest power. For instance, in our example here, the highest power is x squared, so we'll divide everything by x squared. So we'll get if we divide 3x squared all over x squared, we'll get 3. We divide 2x all over x squared, we get 2 all over x. If we divide 5x squared all over x squared, we'll get 5. And if we divide negative 1 all over x squared, we'll get negative 1 all over x squared. So here our answer is going to be 3 plus 2 all over x all over 5 minus 1 all over x squared. So as x approaches infinity, the x this 2 all over x and 1 over x squared also approaches 0. So it will be where there is this 2 over x, which is from the limits at infinity rule, which is 1 all over x n. In our case here, n is 1, and in our case here is n is 2. So for any instance, if we get these kinds of limits or fractions, they will always be equal to 0. They will always be equals to 0. So we will substitute 3 plus we'll substitute them with 0. So it will be 3 plus 0 all over 5 minus 0, which is equals to 3 all over 3. So our horizontal asymptote in our case will be y is equals to 3 all over 5. In our second example, we want to find the limit of this function, which is 2x plus 1 all over x squared plus 3 as x approaches infinity. So for instance here, we will have to divide everything, every value here by the highest power. So our highest power here is x squared, so we'll divide 2x all over this x squared, we'll get 2 all over x, 1 all over x squared, here we'll get 1, and here we'll get 3 all over x squared. So which is this one, x 2 all over x plus 1 all over x squared divided by 1 plus 3 all over x squared. So as x approaches infinity, 2 all over x and 1 all over x squared and 3 all over x squared will always be approaching or equal to 0. So we substitute everything here, or all these values with 0. So it will be 0 plus 0 all over 1 plus 0, which is equals to 0 all over 1, which is equals to 0. And therefore our horizontal asymptote y will always be 0 for our function f of x. Always use these 3 rules for rational functions. So when the numerator degree is always less than denominator, the limit at infinity is always 0. And when the numerator degree is equal to the denominator degree, then the limit at infinity is always equal to the ratio of leading coefficients. And when the numerator degree is greater than the denominator degree, there is no horizontal asymptote. So the limit at infinity is also either either at a positive or negative infinity. So there is no horizontal asymptote. Example 3, infinity with the square root. So find the limit of a function square root of f of 4x squared plus 1 divided by x plus 1 as x approaches infinity. So we've got to divide by x, everything by x, since x is greater than 0, and the square root of x squared is x. So it will be the square root of 4 plus 1 all over x squared all over 1 plus 1 all over x. So as x approaches infinity, the 1 all over x squared and the 1 all over x, as always, it will always approach to 0. So we'll have to substitute them with the value of 0. So it will be the square root of 4 plus 0 all over 1 plus 0. And we'll get a value to be the square root of 4 over 1, which is a 2. So in our example here, the horizontal asymptote y is equals to 2. So at your own time, try to find out a solution to this question, whereby we find the limit of this function 5x squared minus 2x all over 3x, 5x cubed minus 2x all over 3x cubed plus x squared plus 4 of x as it approaches infinity. Yeah.